Okay, in 11.5 we're looking at two different formulas. It's the distance and midpoint formulas. Both of these formulas work when you're just given 2 points. So if you're given 2 points, we can call them x1, y1, and x2, y2. This is just the x-coordinate, y-coordinate of the first point, x-coordinate, y-coordinate of the second point. The distance formula would measure the distance between those 2 points, and that is as follows. The distance is equal to the square root of the difference in the x's squared plus the difference in the y's squared. So here we're asked to find the distance between 3, 4 and negative 2, 1. So just plotting these points, 3, 4 and negative 2, positive 1. We're asking what is this straight line distance? So we're going to use the distance formula, and something I might recommend doing, especially right away, is just writing out what's your x1, what's your y1, what's your x2, what's your y2. And technically it doesn't matter which of these points is your first point or second point, but if this value, if this 3, if we're going to call this x1, then this 4 has to be y1. You can't have x1 with a y2. So I'll just call this first one x1, the second, this y-coordinate y1, the second x-coordinate we'll call x2, and then we'll call the second y-coordinate y2. And these are subscripts. These aren't, we're not squaring 2, or we're not squaring x, or we're not taking y to the first power. We're just putting these 1s and 2s there, saying this is from the first point, this is from the second point. So there's no computation involved with this 2 or this 1. So now we just plug in these values where we see them in the equation. So distance is equal to the square root of x2 minus x1. Well, x2 is negative 2. x1 is 3 squared plus y2, which is 1, minus 4 squared. Okay, let's do some simplifying. Negative 2 minus 3 is negative 5. 1 minus 4 is negative 3. Negative 5 squared is 25. Negative 3 squared is 9. So the square root of 25 plus 9, which is the square root of 34. If we wanted an exact answer, we can go ahead and plug that into our calculator. 34 is not a perfect square. And when we do that, we should get about 5.83 units. So this length is 5.83. So now that you've seen the formula, let's look at where this actually comes from. We have a point here and a point here. But what happens if we make this into the hypotenuse of a right triangle? So you see this length is 3, this length is 5. 3 squared plus 5 squared should be equal to our hypotenuse squared. Well, that's what we just did. We did 3 squared, we had negative 3, but it's the same idea, you still get 9. And 5 squared, 25, add those together, take the square root. All the distance formula is the Pythagorean theorem. That's all it is. It's just written out symbolically. So if you forget the distance formula, but you know the Pythagorean theorem, you're still in good shape. So if you'd like, go ahead and pause the video and try this one on your own. Okay, we're finding the distance between 2, 5 and 0, negative 4. So 0, negative 4 is here, and 2, 5. So we could use our Pythagorean theorem, but we're going to use the distance formula. So our distance, we'll do this quick, is equal to the square root of, here can be our x2, here can be our x1, so 0 minus 2 is negative 2. And then y2 minus y1, negative 4 minus 5 is negative 9. Negative 2 squared is 4. Negative 9 squared is 81. So we're looking at the square root of 85. And we can get an estimation for that if we'd like. Square root of 85 is our exact answer. But if we want a rounded answer, it's 9.22. So these 2 points are 9.22 units apart. So that's how you use the distance formula. It's pretty straightforward. Just don't confuse your x1, x1, y1, x2, y2. That's really all it is. The midpoint formula also deals with 2 points. And what the midpoint formula gives you is, well, the midpoint. So what's the middle point between 2 different points? So if we're finding the midpoint between negative 2, 3 and 4, 5, we're just looking for the middle point, so somewhere in here. And some of you might visually be able to just look and know where the midpoint is, but sometimes it's harder than others. So we do have this midpoint formula. And the computation is pretty minimal with the midpoint formula. All you're doing in the midpoint formula is you're taking, for your x-coordinate, you're taking x1 plus x2 divided by 2, and for your y-coordinate, y1 plus y2 divided by 2. Now think back, if you're adding 2 things and dividing by that same number of things, that's just taking the mean or the average of the 2 points. So all you're doing is you're finding the average value of your x-coordinates and your average value of your y-coordinates. So let's see how this works. Our midpoint is equal to, add the x-coordinates, 4 plus negative 2. You could obviously do negative 2 plus 4. It does not matter. Addition is commutative. And then 3 plus 5, or 5 plus 3, divided by 2. So now let's just simplify. 4 plus negative 2 is just 2. 5 plus 3 is 8. 2 divided by 2 is 1. 8 divided by 2 is 4. Our midpoint is 1, 4. So you can see this is right in the middle of these 2 points. You could think of it as we go down 1 over 3, down 1 over 3. Boom, it's right in the middle. This is our midpoint. It's the average of your x-coordinates and your average of your y-coordinates. The average of 3 and 5 is 4. The average of negative 2 and 4 is positive 1. Last example, feel free to pause the video and try this on your own, just using the midpoint formula. Okay, we're finding the midpoint between negative 1, negative 2, and 4, 4. So here we go. Midpoint is equal to negative 1 plus 4 divided by 2, and negative 2 plus 4 divided by 2. Negative 1 plus 4 is 3. Negative 2 plus 4 is 2. Now, 3 over 2 we can't simplify. That's just 1.5. So we'll just leave that as 3 over 2. 2 over 2 is just 1. So this is 1.51. So our midpoint is over 1.5 and then up 1. And you see this point is right in the middle of these 2 purple points. So that wraps us up for 11.5. Just 2 formulas, just our midpoint formula and our distance formula. Remember, the distance formula is just the Pythagorean theorem written out symbolically. And the midpoint formula is you just take the average of your x-coordinates and your average of your y-coordinates. Hopefully pretty straightforward, but that's it for 11.5.